So you have your 4 pieces of paper. I just grabbed 2 green and 2 yellow. Some of you grabbed 4 different colors. That's totally fine. Okay? Here's what I want you to do. I want you to arrange your paper like this. Sorry, is that better? Can you see them? Thank you. About an inch showing. Got it? Everybody see? Look back here if you need to see. Yes? This is what I want you to do. And then I want you to... I'm choking myself. Here's what I want you to do. Okay? After you have them arranged like this, let me zoom out. That might help a little bit. Okay, so see how I have them long, like portrait, right? I want you to tuck this part in and fold it. But see how I have a yellow here and a yellow here for mine? Okay, and then put a crease. And then you're going to staple. I feel like as juniors and seniors in high school, I shouldn't have to give you instructions on stapling. However, I have had to so far today. So I'm going to continue. Okay. So I put 1 in the middle for the record. Wrong hand. And then I put 1 on the side over here and 1 on the side over here. That's really more than enough staples. You might want to use 4 staples though. Like put 1 here and then 1 like this. There is no need for 9 staples. None. No need for 9 staples. 5 is kind of pushing it, but I'll allow it. Okay? But notice please where I put my staples. Can you see that? Let it focus. It's mad because I'm using colored paper. It's mad. Okay? There's the bottom of the staple. There's the top of the staple. Look at where it is compared to the edge of the paper. I don't put it right at the edge because then it's not going to catch all 4 pieces of paper that are in there. Does everybody understand that? Okay. I'm going to pass the stapler around. Get yours stapled. Oh, I'm stuck. Okay. I'm really stuck. I can't move. So, as you are stapling, here's your warm-up. Okay, here's your warm-up. As you are stapling, I want you thinking about this warm-up. You're thinking about it. You're writing down your answer. You're not talking about it. Is that fair? How would I fold mine so that my 2 yellows were not touching? If I wanted to go green, yellow, green, yellow, green, yellow, green, yellow, all the way down, how do I fold that? Think about that. That's your warm-up. So, for the question, how do you fold it so the middle 2 aren't touching? And then answer that question for your warm-up. Once you finish with the stapler, just, pass it to the next person. Excellent. Pass it to the person you like the best. I'm going to go ahead and pre-crease mine. So if you're done with your warm-up and you want to pre-crease yours, that'll help later on. Remember, you're not talking about the warm-up. You're thinking about it by yourself, but not talking about it. I understand some of you are just helping each other understand the question. That's fine. But no communication about what you think the answer should be, please. And thank you. I see that. Okay, are we almost done stapling? Not yet? Okay, once you finish, remember, pass the stapler on, please. It's called sharing. We don't like to share? Okay, it's fine. You have to today, okay? Okay, time out. You can't staple it closed. You can't staple it on this side right here. You have to staple it on the top edge. If you staple it on this side, it's going to be closed and you won't be able to use it. You need a staple remover? You know how to use a staple remover? No? Okay, let me help you. It slides like this. And then pulls the staple out. Okay? Good job. And now you learned something new today, how to use a staple remover. All right, are we almost ready? How many people still lack the stapler? How many people still lack a stapler? So just your table? Did you pre-fold it? Pre-crease it? Like this? Like that? It'll make it easier in a minute when we go to turn pages. Okay? If it's pre-creased. Almost ready? Okay, this is the front of my foldable. Can you tell what the front is? So if you turn it over, this is the back. Excellent. So here's the deal about this foldable. Okay? You know I'm going to keep my word because it's going recorded for posterity for all time now. Okay? Anytime for the rest of the school year that you feel like you need to use this foldable, whether it be on homework, whether it be on a test, you will always be allowed to get this foldable out and use it if it's yours. So on the back, I would like you to write your name, but not in pencil. I don't want it written in pencil. Why don't I want it written in pencil? Do you think that's ever happened before? Yes. Okay. So write it in pen or marker, not blood. You cannot write it in blood. That's unacceptable. Okay. Especially not someone else's blood. That makes it even worse. God bless you. Okay. I know it's easier to get. Someone else's blood is easier to get, but we're just not going to go there. Okay. Guys, here's the other part about this. While you're searching around for your pens or your markers or whatever, Some of you got dark colored paper because that's what I had to offer you. Some of you got the red, some of the blues are darker, the purples are darker. If you use your pencil today to take notes, you're not going to be able to read it. So today, and pretty much today only, I will let you use pen or marker to take your notes in so that you can read it. Okay? Is everybody okay with that? Okay. So write your name on the back. Oh, so for the record, just so you understand why I have to be very specific and direct with some of my directions last time. Earlier I said on the back, write your name in not pencil. So I had someone write your name in not pencil. And you guys laugh at me when I tell you stuff like that, and then people still do it. No. That's what they thought I meant to do. Okay? This one's mine, so I'm going to write my name. Although this is not my name any longer. This is my name now. At marching contests on the scoreboard, they put up the directors' names. It said Jennifer Weber, Dean Weber, Mish Kingston. They said it right both times they said it. They said Misty Kingston, but on the scoreboard it said Mish. And we laughed. And they even made me a bracelet that I don't have on right now, but you could see where it was because it was so tight, so they're remaking it for me so I can actually wear it. It says Mish. Yeah, and Briette, our drum major, Briette. Yeah. Okay. Okay, you ready? We're on the front now. No, you do not have to draw the smiley face if you do not wish to. I just did because it's exponents and I like exponents. Yes, sir. I didn't write that. Exponents. That's how you correctly spell exponents. It's fine. All right, you ready to go on? So you see how, like, on mine, this looks like orange. It's yellow, okay? But on the board, it looks orange. So I'm going to put the title and the rule on this little tab area, and then we're going to open it up, and I'm going to give you examples right there. Does that make sense? Okay, so the first tab, I'm going to leave it folded down so I know where to put the words, okay? Product of powers. God bless you. Product of powers. God bless you. God bless you. My goodness, get it under control. Product of powers. Okay, so product means what? Multiply. So we're multiplying something with powers. So it actually looks like the general rule looks like a to the m times a to the n. When I'm multiplying like bases, what do I do with the exponents? Add them. So a to the m plus n. You okay so far? So fold that top page up, and I'm going to give you some examples for right here. Okay? X squared times x to the third. Multiplying like bases, what do I do with the exponents? Add 2 plus 3. That took entirely too long. 2 plus 3 is 5. Now, I have a feeling what I'm going to write down next is going to make some of you panic, and I need it to not. X to the 3 halves times x to the 4 halves. Why did I think it would make you panic? Because it's fractions. How is the rule any different than when I don't have fractions? It's not. How do we add fractions? Add the numerator, leave the denominator alone. Now, we can do that because this already has a common denominator, right? So what's 3 plus 4? That was much faster. Good job. And what do I do with the denominator? Leave it. It's a common denominator, so I leave it. And then I'm done. Okay? Okay so far? Oh, do we need to do jazz hands for that? Okay, jazz hands. Yay. Okay. Next tab. Power of powers. Power of powers. Power of powers looks like this. A to the m power raised to the n power. If I'm raising a power to a power, what do I do with those numbers? I multiply them. So we could just write mn, right? Because that means multiplication. I'm going to make sure we understand that it's m times n. Does that make sense? Okay. Everybody have the rule? Okay. X squared to the third power. Now, if we just use the general rule, what do I do with those numbers? So I get x to the 6th, right? Can I please make sure you understand why that's true? X, anything to the third power is that thing multiplied 3 times, right? So I have x squared times x squared times x squared. Isn't that the same thing? X squared 3 times. Well, using the previous rule, I just know, what do I do with with the powers when I'm multiplying like bases? 2, 4, 6. Does that make sense? So this is kind of a shortcut of the rule we just looked at. Does that make sense? Okay. What about this? X to the 1/2 power raised to the third. So remember, I have 1/2 times 3, and when I'm multiplying things with a fraction, I just multiply straight across, right? So I end up with x to the 3/2 power. Exactly. Any questions so far? You got it? Okay. Next tab. Power of a product. Now, what do you think most people have said today when I wrote that down? Well, we already did it. We already did power and product, right? Well, what we actually did was product of powers. So I was multiplying things that were being raised to a power, right? So what do you think power of a product would look like? It means I have a product already, and I'm raising that to a power. So you see the difference? Do you see the difference in these two rules right here? Yes? Okay, good. Are their names confusing? Maybe a little bit. Don't worry about it. What's happening here? What's being raised to the m power? Both of them. So a to the m power, b to the m power. Examples? I have a couple more examples on here than just one, just because different things can happen. Okay? So we'll start with the easy one. How about that? AB squared. Perfect. A squared, B squared. But what if it's something like this? This is where we cry and quit? No, okay. So what's interesting is, aren't I asking you to do 2 rules at one time? I'm asking you to do power of a product, but I'm also asking you to do power of powers at the same time. Are you okay with that? Okay. So what should it end up with being as an answer? X to the 8th, y to the 12th. Oh my gosh, that was so cinchy. 8. Don't let yourself be tricked. Don't let yourself be tricked. Are you ready? To the third. What do you think? 2x to the third y to the 15th is really close. But what is being raised to the power? Everything, right? Everything's being cubed, or everything is being multiplied by 3? Everything's being cubed. So I have 2 cubed x cubed y to the 5th cubed, right? So tell me now, what is 2 cubed? 8. Not 6, because we're not saying 2 times 3, right? X to the 3rd, y to the 15th, yeah. What do you think, what part of that do you think tricks most people? The 2. It's not hard. You just have to think about it. You have to use your brain. It's that thing inside of your skull. Yeah. That you think with. That some of you think with. Okay. A times b to the 2/3 power. A to the 2/3, b to the 2/3. Now, this next one is going to trick you. I'm not going to let it trick you. Is that fair? Okay. It's not even that it's going to trick you. It's that you just don't know yet what I want. This is something new today. It's actually, we're even actually not really talking about it today, but I'm going to go ahead and put it in the notes so that we can look at it several times before we actually get there. Okay? What do you think the most common incorrect answer that people put first is? 8. Right, that is incorrect. I'm saying you are correct in saying that's an incorrect answer. Okay? Because it's not saying 16 times 1/2. The same way down here, we didn't say 2 times 3, right? It's 16 to the 1/2 power. And the new part for you guys today is when we have a fractional exponent, the top, the numerator, is the power, and the denominator is the root. We're going to write it down later, so don't worry about it. Okay? But it's saying the square root of 16. What is that? 4. A to the, now we just follow the same rules as before, right? A to the what? 5/2, good. B to the 1/2. I know this is new. I know it's freaking some of you out. I can tell by your eyes. Please don't let it. Okay? Next tab, you ready? I would like you to try to figure out what this rule is going to look like in your head before we write it down, based on the rules that were above it, especially this one. If product of powers looks like this, what does quotient of powers look like? What is product? Multiply. What's quotient? Divide. So what am I doing? So a to the m over a to the n? Excellent. What does that equal? If I'm multiplying like bases, what do I do with my exponents? Add them. So if I'm dividing like bases, what do I do with my exponents? Perfect. Ready for examples? Okay. X to the 5th over x to the 3rd. X squared. That's fine. I'll wait. You're okay. So what about, can I try to trick you? Okay. So what about if it's this? Thank you. Your first instinct is to say x to the negative 2, right? Oh, we don't want negative exponents. That's in fact one of our next tabs. So I'm kind of ahead of myself. I also don't care because I'm the teacher and I decide. Okay. What if I started here? If I started in the denominator, what's 5 minus 3? Then where would I leave the answer if I started in the denominator? In the denominator, right? What's left in the numerator? And if you don't know that off the top of your head, I need you to remember what's actually happening here. Isn't that the same as x to the 3rd? Isn't this the same as x to the 5th? Yeah? And aren't I saying x divided by x is 1? And x divided by x is 1? And x divided by x is 1? What's left in the numerator? A 1. What's left in the denominator? X times x, which is x squared. I think his brain just blew up. Yeah, that's exciting. Not that your brain blew up, but that you figured out what was happening. X to the 7/3 divided by x to the 2/3. Is the rule any different just because we're dealing with fractions? No. 7/3 minus 2/3? 5/3. Good. We're not going to deal with that yet. Okay. Today I'm just trying to get some notes for you today. But if they don't have a common denominator, we just have to get them a common denominator. Okay. Is that fair? Okay. Next tab. You ready? Once again, I want you to see if you can predict what the rule is before I write it for you. Power of a quotient. Power of a quotient. Based on power of a product, I had two things being multiplied together, then I raise it to a power, right? So power of a quotient should be two things divided, very good, and then raised to a power. Excellent. What's that going to end up being? A to the m over b to the m. Now, I do have just a slight issue with how some of you guys are saying this. I know what you mean, you know what you mean, but you know I have to be careful of your vocabulary, right? So we don't mess up. Because some of you are saying AM over BM. If you're just saying AM, that's things multiplied, isn't it? So we need to make sure that we're saying A to the M over B to the M. Does that make sense? Okay. Not mad. Because I promise if I was mad, you would know. Is that fair? Okay. Notes for power of a quotient. What? What'd you say? It's not personal, it's business. Exactly. It's not business, it's personal. X over y to the 3rd power becomes? Perfect. X to the 3rd over y to the 3rd. Can you do two rules at the same time? A to the 6th over b squared, all raised to the 4th power. A to the 24th over b to the 8th. So why do people not like that as an answer? It's too big. No, we can't. There's no like bases. There's nothing to simplify, right? Is it okay if we get a to the 24th? Yeah, absolutely. It's what it asks us to do, right? 6 times 4, that's 24. I'm done. Okay? I mean, you might think, oh, simplify. But there's not like basis to simplify with, is there? Okay? X over y to the 1/2 power equals? Perfect. Perfect. Next tab. As I alluded to earlier, I don't think I even alluded it to. I think I just told you. It would say negative exponents. A to the negative n is going to end up being 1 over a to the n. I'm going to show you some examples, and then I'm going to tell you a ridiculous story. Are you okay with that? I know you've never heard a ridiculous story from me before, especially like sheep water. Okay. Yeah. That's a story for another time, though. Okay. X to the negative 3, what is that going to end up being? 1 over x to the 3rd. So that seems pretty straightforward, but what about this one? 1 over x to the negative 4th. What's that going to be? Isn't it just x to the 4th? Okay. One more example, and then you get the ridiculous story, all right? Negative 2 x y to the negative 3rd. What does this tab have to do with? Negative exponents, right? So what do I do with the negative 2? Nothing. What do I do with the x? Nothing. What do I do with the y? Put it underneath, right? Except it's not negative anymore. I'm sorry, I accidentally wrote that. Ignore that dot, please. I know you've never experienced a class that almost everyone in the class is silly, but I had a class like that one year, and they kept messing up negative exponents. So I figured if I could get to their level, to the silliness level, and tell them a story, that I could fix it. So here's what I told them. You see this x right here? He's so sad. He's in the numerator. So sad. But when you put him into the denominator, so happy. But if he's in the denominator and he's so sad, where does he want to go? To the numerator. And now, so happy. But look at this one. So sad. In the numerator, where does he want to go? Denominator, and now, so happy. But what about this guy? We can't do anything for him. We can't do anything. Why can we do nothing for him? It's not his exponent that's sad. It's just him as a person. He's just, number. He's not a person. He's a number. I can't do anything about that. All I can do is help the negative exponents be not so sad. And as a ridiculous story as that is, it fixed it. They started getting him right now. So now I tell the story, just in case you don't know and can't figure it out. We can't do anything about this. He's just going to be sad, probably angry also. Okay? But these, we can help these. We can help them be so happy. Got it? Okay. So what about this? So sad. Where does he want to go? Denominator. When he gets to the denominator, so happy. 1 over x to the negative 3/4. So sad. So when you move him to the numerator, so happy. Questions? Is that mathematically sound argument at all? No, absolutely not. That's not a mathematically sound argument. It's a silly story to help you remember. Got it? Okay. Last page does not have a title on the tab. It just has some notes to ourselves. Okay? So first of all, I told you about this before. Now we're going to write it down. If I have a to the m over n power, the numerator is our power. The denominator is our root. So a 2 on the bottom of this is asking for a square root. A 3 in the denominator is asking for a cube root. Exactly. And so on. 4th root, 5th root, whatever. Okay? X to the first power is always x. Anything to the first power is just itself. And anything to the 0 power is always 1. Can I show you why? In a really concrete way. Then you be quiet. 2 to the first power is what? 2. I'm even going to draw you a model. It's 2 squares, right? That's 2. 2 squared is what? 4. I'm going to finish writing this so it's on the video, but you guys go to lunch. Okay? Or stay if you want. Yeah, that's the lunch bell. It surprises us every time. You guys fight to stay. It's okay. Okay? There's 4. 2 squared is 4. You know that, so I'm drawing it like this. Okay? 2 to the third power is what? 2 times 2 times 2. That's 8, isn't it? So the easiest way to draw 8 is like this.